Hello, my name is Vladik Khononov. When I was 9 years old, I had a dream to create my own computer games, so I learned to code. Since then, I didn't try any games whatsoever, but somehow I ended up battling and taming the complexities of enterprise software. In fact, I've got so fascinated by it that I've been doing it for the last 18 years. Currently, I serve as a chief architect for a company called Khononov. The peculiar thing about Khononov is that we've been using domain-driven design since the day the company was founded, and I was invited here to share with you our DDD journey. So, in the first part of this presentation, I will walk you through the various systems from our domain and how we've implemented them. Of course, I won't be able to cover everything we've done, therefore I'll concentrate on 5 bounded contexts that demonstrate the different approaches to DDD that we've tried and the results that we achieved. In the second part, I will use those 5 stories to share some practical advice on DDD, CQRS, event sourcing, and microservices. But before I begin, let's do some hand-raising exercises. Who read this book? Okay, and keep your hands up if you read it beyond the first chapter. Okay, quite a few, awesome. Cool, so let's get started. About 7 years ago, I got a phone call from a friend. He said that he was starting a new company. The business was not going to be simple, but if I joined him, technically, I could do whatever I wanted. And back then, I had a pretty boring job, so I've agreed just like that. Let me show you what I've got myself into. Say you're producing a product or a service. Khononov allows you to outsource all your marketing-related chores. We'll come up with the best marketing strategy for your product. Our copywriters and graphic designers will produce tons of creative materials, such as banners and landing pages, that will be used to run campaigns to promote your product. All the leads generated by these campaigns are going to be handled by our own sales agents that will make the calls and sell your products. And most importantly, this whole process provides many opportunities for optimization. And that's exactly what our analysis department is going to do. They're going to analyze this whole data to make sure that you are getting the biggest bang for your buck, whether it's by pinpointing the most successful campaigns, the most effective creatives, or by identifying the most promising leads for the agents to work on. That's the system that I signed up to build. Since we were a self-funded company, we had to get rolling as fast as possible. Therefore, we started by implementing the first third of our value chain. We had to provide a way for media buyers to manage contracts with various publishers, a catalog for our designers to manage their creatives, and of course, a campaign management solution to run advertising campaigns, which meant not only a management system, but an ad serving and hosting solution as well. I don't know about you, but initially, these business domains sounded terribly complex to me. Fortunately, not long before we started working, I read a book with the words software and complexity in its title, and we already know that quite a few of you here familiar with this book. It wasn't an easy book to read, but luckily for me, I felt that I got a really strong grasp of domain-driven design just by reading the first 4 chapters. Guess how the system was initially designed? Its architectural style could be neatly summarized as aggregates everywhere. Creatives, agency, advertiser, publisher, website placement, each and every noun in the requirements was proclaimed as aggregate. And of course, all those so-called aggregates resided in a huge, lone, bounded context. Yeah, exactly the same monolith that everyone warns you about nowadays. And of course, those were no aggregates, just an anemic domain model. They didn't provide any transactional boundaries, and they had very little behavior in them. All the behavior was here, in a big, fat service layer. Frankly, this was no work of art, right? This design was so terrible, it's like by-the-book example of what domain-driven design is not. However, things looked quite different from the business standpoint. From the business's point of view, this project was considered a huge success. Despite the imperfect architecture and despite our very unique approach to QA, we delivered working software in a very aggressive time to market. How did it happen? And the answer is ubiquitous language. We somehow managed to come up with a robust, ubiquitous language. None of us had any prior experience in online marketing, but nevertheless, we could still hold a conversation with domain expert. We understood them, they understood us, and to our astonishment, domain experts turned out to be very nice people. They really enjoyed and appreciated the fact that we were willing to learn from them and their experience. This smooth communication allowed us to grasp the business domain very quickly and to implement its business logic. Yeah, it was a very big, scary monolith. But for two developers in a garage, it was just good enough. Again, working software in a very aggressive time to market. This diagram sums up our understanding of domain-driven design at this stage. Ubiquitous language and an anemic domain model in a monolithic bounded context. As time passed, leads started flowing in, and we were in a rush. Our sales agents needed a robust CRM, CRM is Customer Relations Management System, to work with. It had to aggregate all incoming leads, group them based on their target markets and brands, and distribute those leads across multiple desks around the globe. Also, the system had to integrate with our clients' internal systems, both to complement our leads with additional information and to notify the clients about changes in the leads' life cycles. Of course, the CRM had to provide as many optimization opportunities as possible. For example, the ability to make sure that agents are working on the most promising leads, to assign leads to sales agents based on their qualifications and past performance, and to allow a very flexible solution for a calculation of agents' commissions. Since all these requirements didn't quite fit any existing off-the-shelf solution, we decided to roll out our own CRM system. Our initial implementation approach was the good old DDD Lite. We'll call every noun and aggregate and shoehorn them into the same huge monolith. This time, however, something felt wrong right from the start. We noticed that all too often we were adding awkward prefixes to aggregates names like CRM lead and marketing lead, marketing campaign and CRM campaign. And interestingly, we never used those prefixes in conversations with domain experts. Somehow they always understood the meaning from the context. And then I recall that there was a chapter with something about context in that big blue book. So I went back, and this time I read the book cover to cover. Finally, I learned that bounded contexts solve exactly the same issue that we had experienced. They protect consistency of the language. Also, by that time, von Vernon's book, Implementing Domain-Driven Design, came out. I read it, and I finally understood that aggregates aren't just data structures, but they play a much more important role by protecting consistency of the data. So we decided to take a few steps back and redesign our CRM solution to reflect these revelations. First of all, we divided our monolith into two distinct bounded contexts, marketing and CRM. We didn't go crazy with microservices here or anything like that. We just did the bare minimum required to protect our ubiquitous language. However, in this bounded context, we were not going to repeat the same mistakes we made in the marketing context. No more anemic domain models. Here we would implement a real domain model with real by-the-book aggregates. In particular, we promised that each transaction will affect only one instance of an aggregate. Instead of an ORM, the aggregate itself will define the transactional scope. And the service layer will go on a very strict diet, and all the business logic will be moved into its corresponding aggregates. We were so enthusiastic about doing things the right way, but soon enough it became apparent that modeling a proper domain model is damn hard. Relative to marketing context, everything took much more time. It was almost impossible to get the transactional boundaries right the first time. We always had to evaluate at least a few models, test them out, only then to figure out that the model we have never thought about before was the correct one. The price of doing things the right way was very high. Time. A lot of time. And sooner than later, it became obvious to everyone. We would not meet the deadlines. And then the management decided to help us. They offloaded implementation of some of the requirements to DBAs. Yeah, store procedures. This one decision did so much damage. Not because SQL is not the best language for describing business logic. The real issue was a bit more subtle. This situation produced an implicit bounded context with a boundary dissecting one of our most complex business entities, the lead. The result was two teams working on the same business component, implementing closely related features with minimal interaction between them. And of course, there was no ubiquitous language. Literally, each team had its own vocabulary to describe the business domain and rules. The Conway's law kicked our asses. The models were inconsistent, there was no shared understanding, knowledge was duplicated, the same business rules implemented twice here and there, and rest assured, when the logic had to change, the implementations went out of sync just like that. Total nightmare. Needless to say, the project wasn't delivered anywhere near on time and was full of bugs. Nasty production issues that had flown under the radar for years, corrupting our most precious asset, our data. The only solution for fixing this mess was to completely throw away the old implementation and rewrite the lead aggregate from scratch, this time with proper boundaries, which we did a couple of years later. It wasn't easy, but the mess was so bad there was no other way around it. To sum it up, at this stage, our understanding of domain-driven design looked like this. Ubiquitous language protected by bounded context, and instead of an anemic domain model everywhere, a proper domain model everywhere. Of course, a crucial part of DDD is missing here: subdomains and their effect on implementation strategy. Initially, we wanted to do the best job possible, but we ended up wasting time and effort on building domain models for supporting subdomains. As Eric Evans put it, not all of a large system will be well designed. We learned it the hard way and wanted to use the acquired knowledge in our next project. After the CRM was rolled out, we've noticed that there was an implicit domain spread across marketing and CRM. Whenever the process of handling incoming customer events was modified, we had to introduce changes both in marketing and CRM. And since conceptually this process didn't belong to any of them, we decided to extract this logic into its own dedicated bounded context. We called it event crunchers. Since we didn't make any money out of the way we moved data around, and we couldn't use an off-the-shelf solution, it looked pretty much like a vanilla supporting subdomain. And we designed it as such. Nothing fancy this time, just some simple ETL-like transaction scripts. And this solution worked well for a while. As our business evolved, we implemented more and more features right here. BI people asked us to put a flag to mark a new customer and another flag to mark a new lead for a specific brand, etc., etc. And eventually, those simple flags have evolved into a real business logic with complex rules and invariants. And guess what happens when you implement a complex business logic as an ETL script? This happens. What started out as an ETL script grew up to be a fully fledged core domain. And since we didn't adapt our implementation strategy, we ended up with a very big ball of mud. Each modification to this code base became more and more expensive, quality went downhill, and we were forced to rethink our implementation. We did it about a year later. The business logic grew so complex it could only be tackled with event sourcing. So we refactored this code into an event-sourced domain model, with other bounded contexts subscribing to its events. We also had a very similar experience in another project. One day, sales desk managers had asked us to automate a simple yet tedious procedure that until then they had been doing manually: calculating commissions for the sales agents. Again, it started pretty simple. Once a month, just calculate a percentage of each agent's sales and send the payments reports to the managers. As before, we contemplated whether or not this was our core domain. And the answer was no. We are not inventing something new here. We are not making money out of this process. And if there was an option to buy an existing implementation, we definitely would. Therefore, not core, not generic, but a typical supporting subdomain. Therefore, we didn't go crazy over its design. Just some active record objects orchestrated by a fatty service layer. Once this process became automated, boy did everyone become creative about it. Our analysts wanted to optimize the shit out of it. They wanted to try different percentages and make those percentages functions of sales amounts and sales sums, and then upgrade the percentages if some business criteria was met, etc., etc. Guess when this implementation has broke down? And it did break down. Again, the codebase became a ball of mud. Adding new features became more and more expensive. Bugs started to appear, and when you are dealing directly with money, even smallest bugs can have some very big outcomes. Ask me how I know. As with crunchers, at some point we couldn't bear it anymore. We had to completely throw away the old code and rewrite it from ground up, this time as an event-sourced domain model. Now let's see what happened here. Just as in the event crunchers, the business domain was initially categorized as a supporting subdomain, but as the system evolved, it gradually mutated into a core domain. We found ways of making money out of these processes. However, there is a striking difference between these two bounded contexts. For the bonuses, we had a ubiquitous language. Even though the initial implementation was based on active records, we could still have a ubiquitous language. You know, CRUD is not a bad word if your domain experts are using it. But as the complexity grew, the language got more and more complicated as well. It could no longer be modeled as active records. And this allowed us to notice the need for a change in the implementation strategy much earlier than in the case of crunchers. We saved a lot of time here by not trying to fit a square peg in a round hole. Again, thanks to the ubiquitous language. That's what our vision of DDD looked like at this point. Pretty much a classic one. We have a ubiquitous language, bounded context, different subdomains, and implementation according to types of subdomains. The fifth bounded context that I wanted to talk about is called Marketing Hub. Our management was looking for a profitable new vertical. They pondered, why couldn't we use our ability to generate massive amounts of leads and sell them to smaller clients, ones we didn't work with before? So they decided to give it a try, and this project was called Marketing Hub. Since this domain was defined as a new profit opportunity by the business, it was clearly a core business domain. Therefore, design-wise, we pulled out our heavy artillery here: event source domain model, CQRS, and back then a new buzzword started gaining a lot of traction: microservices. So we decided to give it a try. That's what our solution looked like. Small services, each had its own database, both synchronous and asynchronous communication between them. On paper, we expected it to be a work of art. In practice, as always, not so fast. We naively approached microservices, thinking that the smaller the service, the better. So we drew boundaries around the aggregates. In DDD lingo, each aggregate became a bounded context on its own. And again, initially it looked great. It allowed us to implement each service according to its specific needs. Only one would be using event sourcing, and the rest will be state-based aggregates. And all of them could be maintained and evolved independently. However, as the system grew, these services became more and more chatty. Almost each of them needed data from all other services to complete some of its operations. The result, what was intended to be a decoupled system, ended up being a distributed monolith, an absolute nightmare to implement and to maintain, of course. And there was another issue we had with this architecture. We had used the most complex patterns for modeling the business logic, event sourcing, and domain model. We carefully crafted all those services, but it all was in vain. Behind this complex architecture stood a very simple business logic. So simple, it could have been implemented using active records. Despite the fact that it was considered a core domain by the business, it had no technical complexity in it. Turned out, the business was looking to make money not by clever algorithms, but by leveraging our existing relationships with other companies. And when technical and business complexities differ greatly, it usually leads to accidental complexities. And this architecture ended up being exactly that, an accidental complexity. The system was over-engineered. So those are the 5 bounded contexts that I wanted to tell you about: marketing, CRM, event crunchers, bonuses, and Marketing Hub. As I said, we had many more systems, but I wanted to concentrate on the one that we learned from the most. So let's see what we learned from this experience. First and foremost, the ubiquitous language. I believe that ubiquitous language is the most important part of domain-driven design. This is the core domain of DDD. The ability to speak the same language with domain experts proved to be indispensable for us, and turned out to be a much more effective way to share knowledge than documents, tests, or even Jira. And more than that, the ability to hold a conversation with domain experts for us was a major predictor of project success. Like in our marketing context, when we just started, our implementation was far from perfect. But the robust, ubiquitous language compensated for the architectural shortcomings, and we were able to deliver the project's goals. In the CRM context, we screwed it up. Unintentionally, we had 2 languages describing the same business domain. This led to lots of problems. And even though we've strived to have a proper design here, because of the communication issues, we ended up with a huge mess. The Event Crunchers project started as a simple supporting subdomain, so we didn't invest in the ubiquitous language. When the complexity started growing, we regretted this decision big time. Even though we had to redesign the project, it would have taken us much less time had we initially started with the ubiquitous language, like we did in the bonuses project. Here, The business logic became orders of magnitude more complex, but the ubiquitous language allowed us to notice the need for a change in the implementation strategy much earlier. And speaking of supporting subdomains, it doesn't really matter what kind of business domain you are working on, core, supporting, or even generic. Our take on it right now is that ubiquitous language is not optional for any of them. We also learned to invest in the ubiquitous language early on. From our experience in the CRM context, it is practically impossible to fix a language if it has been spoken for a while in a company. We were able to fix the implementation here. It wasn't easy, but eventually we did it. But that's not the case for the language. To this day, some people still use the conflicting terms that were originally defined in the initial implementation. Also, if you take care of the ubiquitous language early enough, it's very cheap. Many have the impression that it will be expensive to allocate domain experts' time for interaction with IT people. Not true. Domain experts are sick and tired of software engineers trying to act as if they know better how to solve problems in domains they have absolutely no experience in. That's why our domain experts were so cooperative and willing to help. Bottom line, you don't need a budget for a ubiquitous language. At most, a cup of coffee will do the job. Next, domain types. We all know that according to DDD, there are 3 types of business domains. Core domains, all the stuff that you do differently from your competitors to gain competitive advantage. Supporting domains, the stuff you do differently from others, but it doesn't provide any competitive edge. And generic domains, all the stuff that everyone is doing in the same way. It's a common practice to use this categorization to drive design decisions. For the core domains, use the heavy artillery, domain model, or event sourcing. Supporting domains can be implemented with some rapid application development framework. And generic domains, in many cases, are cheaper to buy than to implement yourself. However, for us, there was a big problem with this model. Companies, and especially startups like ours, tend to change and reinvent themselves over time. Businesses evolve, new profit sources are evaluated, others neglected, and sometimes unexpected opportunities are discovered. As a result, business domain types change accordingly. Speaking of our company, I think I've experienced almost all the possible combinations of such changes. For example, event crunchers and bonuses. Both of them started as supporting subdomains. But once we discovered ways of making money out of these processes, they became core subdomains. In the marketing context, we implemented our own creative catalog. Nothing really special or complex about it. However, a few years later, an open source project came out, and it offered the same functionality and even more features than we originally had. So we threw away our implementation and replaced it with this product. What happened here? A supporting domain became a generic one. In the CRM context, we had an algorithm that evaluated and identified the most promising leads. We refined it over time, tried various implementations, but eventually it was replaced with a fully managed machine learning model running on AWS. Our core domain became a generic domain. We've also seen our marketing hub context. What started as a core subdomain ended up being a supporting one, since the competitive edge resided in a completely different dimension. And we have quite a few examples in our industry of companies that turned generic and supporting domains into their core business. For example, Amazon and their AWS cloud. Now, once this kind of change happens, your design should evolve accordingly. Failing to do so in time will lead to lots of accidental complexities. Hence, instead of making design decisions based on domain types, today we prefer to reverse this relationship. For each domain, we start with its implementation strategy first. No gold plating here, the simplest design that will do the job. And from this design, we deduce the domain's type. The first benefit of this approach is less waste. Your implementation is driven by the requirements at hand. It's not going to be over-engineered as it happened for us in the Marketing Hub context. And it's not going to be under-engineered as we did in the bonuses context. Second, reversing this relationship creates a dialogue between you and the business. You see, sometimes business people need you as much as you need them, because if they think that something is a core business, but you can implement it in a day, then probably some questions should be asked about this business. On the other hand, what if a domain is considered a supporting one by the business, but it can only be implemented with domain model or event sourcing? Things get interesting here. There are two options. First, maybe the business people got over-creative over their requirements. It happens. In such cases, the requirements can and should be simplified. Second, it very well might be that the business can employ this domain, the complexity of this domain, to gain an additional competitive edge, as it happened for us with the bonuses module. In such case, you are helping your business to discover new profit sources much faster. And by the way, designing this implementation strategy is pretty simple. I have a couple of very simple heuristics to streamline this decision-making process. The most important question you have to answer here is, how should the business logic be modeled in code? And here we have four options, four patterns: transaction script, active record, domain model, and event-sourced domain model. You can decide which of these patterns to use by answering a few simple questions. First, does the domain in question deal with money directly, require deep analytics, or require an audit log by law? If the answer is yes, use the event-sourced domain model. Second, how complex is the business logic? Is it more complex than some input validations? Does it have complicated business rules and invariants? If it does, use domain model. Third, if on the other hand the business logic is simple, then how complex are the data structures? If you've got some complicated object trees, go with active record. And lastly, if the answers to all those questions were negative, use a simple transaction script. Once you've decided which of these patterns to use, it's a trivial job to map a suitable architectural pattern. In most cases, event sourcing requires CQRS. Domain model requires hexagonal architecture. Use layered architecture for active record, and for transaction script, in many cases, you can even do away without layers. However, there's one exception here, and that's CQRS. CQRS can be very beneficial not only for event sourcing, but for any of these patterns, and I'll get back to it in a minute. Now, let's say you've chosen an implementation strategy, but over time, it started breaking under its own weight. For example, you've been using the active record pattern, but maintaining and modifying the business logic became painful. This pain is a very important signal. Use it. It means that the domain has evolved, and it very well might be that it's time to go back and rethink its type and implementation strategy. If the type has changed, talk with the domain experts to understand the business context. If you need to redesign the implementation strategy to meet the new business realities, don't be afraid of such change. Once the decision of how to model the business logic is made consciously, and you're aware of all the possible options, it becomes much easier to react to such a change and to refactor your implementation to a more elaborate pattern. Now let's talk a bit more in depth about CQRS. Historically, CQRS is closely related to event sourcing. If you are doing event sourcing, in almost all cases you need CQRS. But it's crucial to understand that event sourcing and CQRS are not the same. Instead, they're two conceptually different patterns. Event sourcing is a way of modeling a business domain. CQRS, on the other hand, is an architectural pattern. It allows you to represent the same data in different persistent models. For example, for event sourcing, you have the event store for writing and projections for reading. Same data in different models. And we found that CQRS can be very beneficial for all kinds of business domains, even for those implemented as simple transaction scripts or active records. In such cases, you can do projections out of the persistent state. I call them state-based projections. By using CQRS, we've tackled lots of complexities in the marketing context, despite the fact that the vast majority of the domains in this bounded context were implemented as active records. And finally, let's talk about the bounded context. At Internobus, we've tried quite a few strategies for decomposing a system into bounded contexts. First, we tried linguistic boundaries. We split our initial monolith into marketing and CRM contexts to protect our ubiquitous language. Next, we tried domain-based boundaries. Most of our business domains were implemented in their own bounded contexts, for example, crunchers and bonuses. We also tried dedicating a bounded context for a single aggregate. This approach had very limited success in the Marketing Hub project, but later on we extracted a lot of business entities out of the marketing monolith into dedicated bounded contexts. And this time, this approach worked much better. And finally, I also shown you how we dissected an aggregate into two different bounded contexts. This decomposition strategy can be called suicidal boundaries. Don't ever try this at home, okay? But seriously, as this paper says, correct boundaries are important for a peaceful coexistence of systems and teams in our case. So after trying out many ways of doing it, I want to show you the strategy for setting the boundaries that we are using right now. As Udi Dahan said, finding boundaries is really hard. There is no flowchart for that. This statement has profound implications. Since there is no flowchart, the only way of finding the right boundaries is by making some trial and error work yourself. Which means, by definition, there will be mistakes. There is no way around it. So let's acknowledge this and only make mistakes that are easy to fix and try to avoid doing the fatal ones. In our experience, it is much cheaper and safer to extract a bounded context out of a bigger one than to start with bounded contexts that are too small and merge them later. Therefore, I always prefer to start with bigger contexts and decompose them as more knowledge is acquired about the business. How big should the initial boundaries be? The heuristic that works best for us is the less you know about the business domains, the wider the initial boundaries are. So for more complex domains, start with bigger boundaries. But for simpler ones, like supporting subdomains, you can start decomposing a bit earlier. When we try to decompose to find great bounded contexts early on, as in the case of Marketing Hub, we ended up with a distributed monolith. On the contrary, the marketing context started up as a monolith, but it was decomposed later on, We extracted campaigns, publishers, creative catalog, events into separate bounded contexts. And again, it is evident even here. The simpler the domain is, the more narrow are its boundaries. Hence, again, our policy is start with bigger boundaries and decompose, only if needed, of course, as you gain domain knowledge. Those are the 5 practical advices I wanted to share. Ubiquitous language is not optional. Domain types are going to change. Embrace these changes. Use them to make your design stronger and more resilient. Learn the ins and outs of the 4 patterns of modeling business logic. Use CQRS to represent the same data in multiple models. And start with bigger boundaries and divide as you gain domain knowledge. And to sum it all up, I'll quickly summarize our current approach to implementing domain-driven design. We always start with ubiquitous language. To protect the language, our initial decomposition strategy adheres to the linguistic boundaries of the language. For each subdomain, we decide how it will be implemented by following the simple heuristics I've shown you. From this design, we deduce the types of business domains at play and verify them with the business. And finally, as more domain knowledge is acquired, we decompose the bounded context even further into more fine-grained microservices. But again, only if there is a good reason for doing it. And if we compare our vision of DDD now to the one we started with, I would say that the main difference is we went from aggregates everywhere to ubiquitous language everywhere. And that's it. Thank you.